welcome to Down to Earth with Terry Virts, where we talk about what matters down here on planet Earth. If you love the podcast, don't forget to subscribe and give us ratings wherever you listen to it. Today, I'm super excited to have two guys with us. Will Bruey is the CEO and Jon Barr is the COO of Varda, an in-space manufacturing startup company. They were both SpaceX alum before coming to Varda, and we're going to talk about all things space and business today. So Will and Jon, welcome to the podcast.
Thanks for having us.
Yeah, thanks.
It's we've been talking for, I don't know, a year now. Will, it's been a while about this adventure that you went off on. And I just want to hear from both of you. Like, how did you guys get into space? You're obviously fairly young. You know, you're not 20-year-olds, but you're also not 60-year-old, old guys. So what got you into aerospace?
Yeah, it's funny. I remember now that you just mentioned it. I remember when I was telling our mutual friend, Brendan, about it, and he was like, oh, you got to meet this guy named Terry. But yes, that was about a year and a half ago now, just over a year. It was in September of 2020. But the reason or at least I got into aerospace was because I kind of wanted to be you when I was a kid. I was just brainwashed into wanting to be an astronaut. So I thought that was the hardest engineering challenge. And so I remember when I was at the career fair in college, I just searched space and went to the company that would take me. Yeah.
Right.
Yeah, my story is honestly pretty similar. I was in college, and it was right around the time of kind of the new space was just budding. So SpaceX and even Blue Origin was around, and I had an early friend, a couple folks out of school that went to a couple early hires at SpaceX. They were like, oh, you got to try it. You got to go out to California. There's all these new companies out there. It's, if you could be a part of anything, you probably would have been part of Apollo. And so I was like, all right, yeah, that seems cool. I don't have a lot to lose right now as a college kid. So kind of jumped on it, and I guess didn't really have a chance to look back. So I'm here today.
That's awesome. So, which is really encouraging to hear that, guys are getting inspired. Because a lot of times it's like, oh, kids these days, whatever. And I have found in my experience speaking and talking to different groups, man, the young people are so interested in space. Not all of them, obviously. The ones who are interested are really interested and really talented. So, Will, we have a similar background. Can you tell me about where you grew up, where you went to college?
Oh, that's right. I forgot. Yeah, you're from York, around York anyway. You have family there. So I was born and raised in Lancaster County, Pennsylvania. So that's Amish country. And I spent the first 18 years of my life there before heading to college. And it was a pretty standard Levittown type upbringing, suburbia, work hard at school. It was pretty stereotypical upbringing.
The crazy thing, my podcast guests, the last one I had is a guy named John Seal. He's an Australian filmmaker who was the director of photography for Witness.
Oh, yeah.
So I just watched that show. I hadn't ever seen it, I don't think, and it was all anyway.
So remind me, because my dad works works with a company that works at the York Hospital, and I think you have a family member there, right?
Yes, my uncle. They left York 20 years ago, but for 20 or 30 years, he worked at the York Hospital.
Wow. What a super small world.
He was a radio DJ, and then he ended up working, I think he did public affairs at York Hospital, which is amazing. It's a small town. Actually, one of the early capitals of the United States.
I forgot about that. That's right. Yeah. I think even Lancaster was capital for one day, exactly, as their claim to fame. Yeah.
As they were walking from New York to Philadelphia.
Yeah.
They stopped in New York. So where'd you go to school?
Cornell.
Oh, okay. So smart kid. Penn State was actually one of my backup plans. How about you, J Bar? Where'd you grow up? Where'd you go to school?
Yeah, I'm from Michigan, grew up in the Metro Detroit area. I went to school in Ann Arbor. So also a big aerospace school.
Yeah. So Penn State was my backup for astronomy. I went to the Air Force Academy, but if I didn't get in, I was going to go to Penn State. But my family was trying to get me to go to Michigan because there was a lot of Michigan engineers at NASA at the time. And I'm like, man, Maryland's cold enough. I don't want to go to Michigan.
Yeah, it was funny actually. As far as degrees go, when I was there, I started as an engineering physics major and found out my degree wasn't accredited. So basically chose aerospace because it sounded the coolest in the catalog. And from there, it was just very serendipitous with the whole new space industry coming up then.
Oh yeah, that was the right time.
Yeah.
So I started out as an astronautical engineer for 2 years, and then I was up all night till 3 a.m. debugging a Fortran program,
Oh,
and
classic.
I misspelled the word read, and I went in the next day and changed my major to applied math because basically the same stuff with less computer programming, and I didn't want to, I wanted to have a life. I didn't want to spend my whole life debugging programs, which is, speaking of having a life, so you guys end up at SpaceX.
Yeah.
Speaking of not having a life, one of the senior NASA guys here, his son went to work at SpaceX, like 25-year-old kid.
No.
And he was really worried for his life. He was worried that he was going to die because he was working so much. So,
it is not. It's I love that there's like that stereotype perpetuates.
Yeah.
But yeah, unfortunately, it's not actually that bad.
They give you Christmas off.
Yeah, they give you Christmas off.
But tell us about SpaceX.
Yeah. I actually think I got stuck in Cape Canaveral on Christmas one.
Well, hey, I worked. You know what I used to do? I was at Capcom for years at NASA, and I used to always volunteer for Thanksgiving, and that way I had Christmas off.
Nice.
And I'd volunteer for Orbit 1, which is like midnight to 8 a.m. So I'd go work that and then take a nap, and then I was like back to normal. So that was I worked every Thanksgiving for years and years and years, but that allowed me to have Christmas off when I had little kids, which was, you don't want to miss Christmas when you got 2 and 3-year-olds. So what was it like at SpaceX? You guys come out of college, 21-year-old, wide-eyed, and this crazy South African wants to launch rockets. And what year did you get there?
What did we both get there? 2011 or something like that? Yeah.
Okay.
Yeah.
I was the robotics branch chief, and we were busy getting ready for robotics capture of that first cargo demonstration. Because for years it used to fly in formation, and we'd have to grab the SpaceX capsule, the Dragon, and attach it with the robotic arm. So that was my 2011 and 2012. 2012, I think, was the first flight. So you guys got there right when they were first flying.
Yeah, it was the summer before, I think.
Yeah. So it wasn't too bad, although I have one funny story, which was from those early days. And we had a super, super cool team. And yeah, kind of what you are describing is a bunch of young folks straight out of college. Mm-hmm. We didn't really have families or mortgages or anything like that. And we were just working all the time. And there are plenty of late nights. It's like 3 a.m, and you're scrounging for food in the kitchen. And
Google feeds you and Apple feeds you. Does SpaceX feed you?
Yeah, there was some food back then, but there was one night in particular. I just remember we couldn't get stage 1 to work for checkouts, and it's probably 5 or 6 of us down there, and we're debugging it, and we're like really fighting the thing, and we just can't get it to work. And I remember turning to my buddy Dennis at the time, being like, there'll be one day where we look back on this nostalgic, and we'll all be happy that we were here and reminiscing about it, even though we're all totally miserable right now. And sure enough, 2 years ago I got married, and Dennis is sitting at a table at the wedding, and it's basically our old team from SpaceX, and everyone's reminiscing about that night. And Dennis is like, dude, you totally told the future. Like, you knew, like, this is the moment that everyone's reminiscing of how glorious it was back then, even though at the time it was a rough go.
Shared misery is the best way to make life.
Oh, absolutely. Yeah. You know that from the mission or the Orbit 1 shift. It's the same story there.
Yeah. There's definitely a camaraderie. It's like the battlefield. It's not Normandy, but it's something, like that. I remember when I was the robotics guy, we had the first pump module failure, and it was an emergency because the station was losing cooling. And then at the last minute, we realized that the robotic arm motion that they had to do, because it's a big 1,000-pound pump, was going to hit structure. and the computer program missed it. And so I was in there manually trying to figure out how to fly. And it was a spacewalk. So you wake up at a specific time there. It's like a launch time. You can't delay it. And the program manager was on the phone with me at, I don't know, 5 a.m. Terry, are we going to get this done? And I was like, yes, sir. If you hang up the phone, I'll get it done. And anyway, we got the robotic trajectory at the last second. So it was one of those similar kind of things.
I was actually just telling the team on Monday, it's always fun when something goes wrong, if you can acknowledge the fact that you're actually at the beginning of an engineering war story like that. So always looking out for good opportunities like that.
As long as you can fix it, then that's good.
Yeah.
It doesn't cost too much either. So you're working, it's hard work. It's probably eye-opening. I mean, it's like when you join the military, they tend to give you a lot more responsibility than you get if you went to Ford, right? Or whatever, AT&T. It's going to take you forever before you're in charge. In the military, they kind of throw you in the fire. Was it like that at SpaceX with all these young people around?
Yeah, absolutely. It was the first time in my life when I was like trusted to make a design choice without being checked by a professor. Right. So and I don't know how it was at other companies, only because obviously I only have that one data point, but it seemed like we had a lot of freedom, autonomy, and lack of safety net. I'm sure there was, guidance from management, and they were looking over our shoulders like guardian angels, but at least as the perceiver, it certainly seemed, we were never, we had full authority over whatever piece of hardware deliverable we were responsible for.
How old were you then?
23.
So you're really reaffirming my decision to leave NASA, to not fly on a SpaceX capsule. Thank you. I feel much better. Which is pretty amazing, and very cool. Will, you have I think you had a passion for flying even before you came to SpaceX, right?
Yeah, actually.
About your flight, you tell me about your flight.
Sure. So I've always wanted to be a pilot, but never really had the chance until going to SpaceX, because it was the first time when I had disposable income but no social life. So I was like, oh, before I make friends here, a lot of like J Barr and the rest of a lot of the folks here at Varda were kind of friends we made along the way, right. But before we had really gotten to know each other, I took those first 9 months of being in California to get the pilot's license and fly regularly up, to this day for sure.
Yeah. You had a story, I think it was an engine out. I remember you had like the engineering data of all this stuff. That was really impressive.
That's right.
That was back in York. That was back in Pennsylvania, or no, Frederick or something.
So I did actually. Yeah. Okay. Actually, now that you mentioned it, I had 2 of these instances. But yeah, there was one going into what was it? It's one of the 3 GA airports in the DC area. Mm-hmm. But yeah, I was on final approach and I hooked up some like custom avionics for like hobbyist stuff in the avionics bay of the plane, and I drew too much current. And so the fuel pump, I had 2 fuel pumps in series. One was a mechanical fuel pump driven by the engine, and the other was in a backup electrical pump. And so when I was on final approach, I pulled throttle. So the engine's already going a little bit slow, and I had just done some maintenance on it, and I had tweaked the mixture ratio at idle, and it was a little bit too lean. So the engine cut out. And so since the engine cut out, the engine driven fuel pump also cut out. And so I saw like, the engine went off and I saw the fuel pressure go to 0. And then I looked up and I was like, wait, but my electric fuel pump is on. And then I looked at my EMS, the engine monitoring system, and it was just zeros all over the place. So I was like, oh shit. So I basically did, exactly what you're supposed to do is, I was already on attitude because I was on final. And so I basically just did full mixture, full throttle, and dipped the nose just a little bit so that so the prop would windmill, and then the magnetos caught, and then the engine driven fuel pump kicks back in. But that was it was pretty cool. I captured all the data. Luckily the custom avionics that led to my secondary failure survived the brownout and captured all the data, so I was able to reconstruct what had happened. And so I was able to be like, oh, I did this problem with my own engineering.
You caused it and you solved it. That's cool. That's an amazing story. The fact that you're so analytical and you had all this data is pretty awesome. The F-16 had a problem when they in the like late 80s. We had this system called Lantern low altitude night missions with a terrain following radar. And I did that for a year in Korea in the early 90s, but there was so much electrical draw, it would cause what they call a brownout, which doesn't sound great, but they're talking about electrical brownout. The and the F-16's electric jet, everything would go down and then it would come back up. And as pilots, we were not happy about that. Because it's nighttime, literally everything blacked out, and you can't fly the jet without electricity. So, but the Air Force did this safety analysis, and they said the amount of jets they're going to lose compared to how much it was going to cost wasn't worth the cost. So they didn't ever fix it.
Oh, geez.
Whoa.
Yeah, so my introduction to probabilistic risk analysis. Second lieutenant.
And this happened to you while you were in flight?
No. But it was one of the things, we tell flying stories. Hopefully, most companies, you should share stories. Every organization should have that ability to share stories. So it was just one of these known problems that we had in the F-16, the brownout.
So you had to just have that in the back of your head every time you went flying?
Yeah. At least they didn't fix that. So how many years were you at SpaceX then before you decided to kick off on your own?
I was there for just under 6, and you were what, 9?
I was, almost 9.
So that's like an entire career in SpaceX years.
It was a long go. I got the wrinkles on my face to show for it now.
We need to go into the weightlessness, and then that'll wrinkles. So the attitude, it's a bunch of 20-something-year-old engineers. You're gung-ho. You want to go to the moon and Mars and stuff. It seems like a startup kind of culture. It's not Silicon Valley, but I think it has, at least getting to know the few people at Varda that I know, it has elements of Silicon Valley startup kind of vibe.
Yeah, totally. And I think one cool thing now with the budding aerospace industry and kind of new space 3.0 is essentially that generation has gone out because folks kind of know how to do it now. They can build flight hardware, they can fly rockets, they know what's it takes.
New space 3.0? Tell me, what's 2.0, what's 3.0?
It's a good question. We've been using it colloquially, but they kind of call the budding, especially SpaceX, Space 2.0, these new companies coming out, other than the Lockheeds and the Boeings and the Northrops and those guys. And
that was Space 1.0.
Yeah, right. Kind of the classic aerospace.
2000s.
Yeah.
Yeah, 2.0 being kind of the commoditized launch, or the launch market that's now becoming a little bit commoditized with all the small launchers, and 3.0 being what do you build on top of that?
Okay, applications. So let's unpack that. Who commoditized the launch industry? I think I know the answer here, but
well, I mean, it's still becoming commoditized, I think, but the reusability aspect, I think, spurred the small launchers to believe that there is a world where we can go to space in much the same way of airplanes. That was kind of the first kind of proof of concept that, okay, it's very much doable from a physics perspective and engineering perspective.
To reuse the
reusable booster is I think the enabling technology. And then the additional that, and I would say also coupled with the miniaturization of computing to allow satellites to now be smaller, allows for a small sat market to develop as well. So those two superimposed on each other, and you get kind of the market we're in now.
Right. So obviously SpaceX is the most familiar name in the launch industry, right? What they've done with Falcon, and what you guys did and what SpaceX has done is miraculous. Mike Griffin, when he was administrator, gave the first, I think it was called COTS contract to SpaceX in 2005. It was basically, let's just give them some seed money and see what happens. You blew up a bunch of Falcon 1s, and then eventually the Falcon 9 started launching, which is good. The best thing to do, I think, is to fail quickly. Like, you want to fail as soon as you can, to figure out, can you fix it and do it in the right direction, or is this just never going to work and let's move on to something else? Was like fail fast? Was that a philosophy there at SpaceX?
Yeah, I would say so. It always comes with a caveat of smart engineering. I think the additional layer of nuance there is, I would say, test your hypothesis quickly so that you know. And then if you're pushing the boundary of engineering achievement, then by definition, a lot of those hypotheses are going to result in failure. But it was always one of these where, it's okay to fail fast. It's okay to test fast, but that doesn't mean that failure necessarily felt that great. I remember, there was a deafening silence when even Falcon 9R, which was like the reusable prototype in between Grasshopper, which was the first, and then Flight 6, which is one of the ones we tried to land softly, and it was just a prototype vehicle in Texas, but it still failed catastrophically, and there was a deafening silence in the entire mission control.
I love that. We'll test your hypothesis quickly. That's better. That sounds better than fail quickly. If you succeed quickly, that's even better, right?
Right, exactly. Yeah.
So test your hypothesis. I love that. That's going to be one of my quotes. That'll be the when I tweet about this episode. That's what
Nice.
I love that. Okay, so there's SpaceX. There's other companies too. I'll give you guys a little bit of shit here because you guys were the second to do the reusable land the first stage. Most people don't know that. Everybody gives Elon credit for that, but
are you talking about like DCX or?
Well, DCX, yeah, you're right. Blue Origin wasn't even first. Yeah. DCX was first back in 1993.
Maston Aerospace was out there too. They kind of had a lunar rover type thing out in Mojave, which is super cool if you ever watch their videos.
But you guys were the first to do it with an orbital vehicle, which is a lot hard. That's a lot harder than just lifting it up and coming right back. Your guy was going 1,000 miles an hour or thousands the wrong direction and had to fly.
Yeah, I think there's one of the biggest misconceptions in the public domain is the difference between orbit and space. And so the way I try to describe it is, if you imagine you're running off a cliff really fast, the faster you run, the farther you'll go before you hit the ground off the cliff. And if you imagine just running faster and faster and landing farther and farther, just continue that thought experiment until you get to the point where the Earth's curvature kind of curves out from under you. And then you can kind of start to imagine orbit. But when you think of it like that, you're like, oh, you got to go really fast sideways and only kind of fast up.
Right.
Also, Terry, apologies. Are you referring to shuttle?
Shuttle? No. I'm talking about reusing the rocket itself.
Okay, gotcha.
How Blue Origin did, I don't know, it's like a few months before they landed their New Shepard first stage.
Yeah, gotcha.
In Western Texas. Although let's talk about the shuttle, because everybody knows how dramatically SpaceX has reduced launch cost, but they just increased the cargo cost by 50% for NASA. And when you do the math, like the dollars per kilogram or per pound, whatever, we actually pay more now on a SpaceX cargo ship than we did during the shuttle program.
No kidding, really.
Wow.
That payload bay in the shuttle is enormous. I mean, that was an engineering feat.
The whole shuttle was incredible. It's the most amazing. It's the most amazing flying machine ever built. I mean, we strapped an airliner to the side of a rocket, sent it into space, and then reused it. The orbiter is bigger than little A319s or whatever. So it was an amazing thing, but the cost has not come down that much. And I did this panel at Goldman a couple of years ago. We were talking about the economics of space and how much reusability saves. And of course it saves money because you don't have to build rocket engines, but it also costs because there's a lot of weight in that first stage for landing gear and for the propellant you have to fly back. And if you're using that weight for landing, you're not sending stuff into space. And there's some refurbishment. I think SpaceX probably does that pretty cheaply, but there's some cost. So in other words, it's not like a 90% reduction in cost, I don't think. Or what do you guys think? Like, how much does a reusable first stage save in terms of dollars?
Certainly not yet. I think from first principles, if you could reuse it, the refurbishment cost is essentially an operational optimization problem.
Right.
Whereas the rocket equation is not one you can really get out of. Right. So I think it comes down to how quickly, what the refurbishment cost is and what the cadence is. Right. So, we were targeting 10, I think, when we were there. But, if you can get that higher, then the cost just drops. And there is a little bit of there is a monopoly aspect to it too. So, when does the cost actually super get driven down?
Right. The reason SpaceX increased cost by 50% was not because they're paying you 50% more, is because there was nobody else delivering cargo. And if I was producing Coke and there was no Pepsi, these things would cost a lot more than they cost. So. And we used to joke for the shuttle that it only cost a little bit more to reuse the solid rocket motors than it would be just to build new ones. And so, but we dunked those things in the ocean.
Yeah.
Right. If you took your Ford Expedition and dunked it in the ocean, you could reuse it, but it would be cheaper just to build a new one. Right. So,
I remember actually early when we were looking at reusing stage one, we were looking at some old shuttle academic papers, and the two drivers for reuse of the boosters wasn't actually flight. It was the salt water, which you're referencing, and then it was the smack down load. So kind of like lands like a pencil, and then it hits the ocean.
The last few years, they got some really cool cameras in the end of the solid rocket motor, so that when they separated, which is amazing, when that motor, it's an AMRAAM missile motor aimed right at your head, like 10 feet from your head. And it was we were counting down the time, and I was a pilot. So I was like, all right, crew, stand by for a little bang. And it was like, and Steve Robinson said, or a big one. It was a funny moment, but they put some cameras there. So it's really cool to see these rockets tumbling, and they keep on going up for a minute or two, and then they start coming down, and you see them hit the ocean. And I mean, everything about that was incredible. And that orange tank, on the shuttle, the fuel tank, it only weighed, I think, at the end of the program, when they improved their friction stir welding techniques and Michoud here in Mississippi, it only weighed like 58,000 pounds. So wow. A 58,000 pound structure held 4 million pounds of mass at launch, accelerated it at 3 Gs with 500 knots of wind air pressure on it into the vacuum of space with thousands of degrees of rocket fire on it. Think about all the engineering challenge that went into that external tank. It was something I really appreciated it. Anyway, rockets are cool, and SpaceX is about rockets and also about the cargo ship and also about Crew Dragon. Now they took the cargo ship and put some seats in there, and there's the Crew Dragon, but they're also doing this constellation of internet satellites, right? And I want to talk about that because I think this is one of the biggest threats. This is one of the biggest problems that nobody talks about, and that is space debris. So I don't know what you guys think about this. This is something I like. I had a guest on a few months ago that we talked for an hour and a half about space debris.
Wow. My first initial thoughts are, of course, Kessler syndrome would be really a sad situation. And I'm sure you've talked about this before when you were talking about orbital debris, but as a quick refresher is it's a chain reaction that'll occur when if two satellites were ever to collide, and the debris would just create many more bullets, which means they're going to hit other satellites, which means more bullets, and you get an exponential growth of shards essentially whizzing around low Earth orbit that in the most severe case would cut off access to space for humanity for a while. The saving grace.
How long is it?
Well, of course, it depends on, there's different levels of Kessler syndrome. It depends on the altitude in which the debris field and cloud is. The lower it is, the better, of course, because that means, the lower something is, the sooner it will decay, since the atmosphere never really officially cuts off. There's always a little bit of drag force. And so as I'm sure you know from station, they do station keeping every once in a while to give the station a little bit of boost, and similar story for all of satellites. So if the constellation is low enough, then it becomes less of a problem, because then Kessler syndrome will eventually go away. It's not a permanent illness. But if you had that situation in, say, GEO or even so that's geosynchronous orbit, 6 Earth radii away from the Earth, or even a little bit closer, like where GPS satellites are, then you could get a significant problem. The blessing there is that when the higher you go, just because as the concentric sphere goes out, the less chance you have of Kessler syndrome, only because you have more space in between satellites. But then the more severe it would become if it ever occurred. So as humanity departs from Earth over the course of generations, it'll definitely be something to keep an eye on. Luckily, like at Varda, we kind of have we luck out a bit because our optimization function puts our spacecraft very low, so they have a pretty short decay time. So we get a little bit of a get out of jail free card to some extent.
No, absolutely. So to run these numbers, so the space station is at 400 kilometers, 250 miles. It's a few decades, right? If we just stopped reboosting the station, the drag would slow it down. It would slowly come down, and it would burn up within 10 years, 20 years, 30 years, something like that. But these constellations, help me with the names. Boeing has one. SpaceX has the most famous one, Starlink. Airbus, Blue Origin. There's a few other companies, and these are tens of thousands of satellites. And these are not at 400 kilometers, they're at 600 kilometers or at 1,000 kilometers. There's a couple of different elevations, and debris at those altitudes is forever. Literally, humans in the year 2500 are going to be really pissed at us. They're going to be watching this podcast angry at us because we left a massive mess for them in orbit. And there's no regulation, am I right? There's not like the FAA, if you want to fly to Paris, you have to get approval from the FAA to do that. And ICAO, the ICAO, there's nothing like that for space debris. And Varda, by the way, I don't think you're going to be launching tens of thousands of satellites.
Yeah, you're right. It's more like hundreds of thousands.
But they'll be at low altitude. So
right. It's interesting because sorry, go ahead.
Oh, well, I was going to say, it's also, we want to bring it back.
Right. We lose money if we don't bring the material back. So
that's just dollars going out the thing. So you're probably more interested in having a reliable deorbit capability.
Exactly. Yeah. It's pretty interesting because, like most satellites, their optimization function of what altitude they want to be in depends on the constellation, who you want to reach, and what other radio transmitters you want to communicate with. But here, since we're essentially using microgravity to capture value so that we can create unique products, since you can't simulate microgravity on Earth.
Microgravity. Yeah. NASA always uses that term. It sounds kind of nerdy.
It is. If there was no mass in the universe, you would have zero gravity. And microgravity just means that if you imagine 1G is what you feel on Earth, then micro would be 1/1,000,000th of that. So very, very small. For the majority of physics, it's almost zero. But because, like you said, we're extra nerdy, it comes with a little bit of an extra technical precision in the terminology. So, microgravity, zero gravity, they're essentially the same thing when it comes to our value proposition, which is just the fact that there's four fundamental forces of physics, and all of engineering are built on top of that. And so at Varda, we basically can turn off one of those forces for the manufacturing engineer. And so there's gravity. So if we want to do a special process or a chemical reaction that results in a better performance when not under the force of gravity, then we can take that to orbit, perform that manufacturing process, and bring the result back down to sell on Earth. And so since everything that we put into space, we only make money if we also bring it down. That's the unique aspect of Varda compared to any other satellite company. We actually want to be as low as possible because in space you have to spend fuel to get home as well. You can't just fall down, and you have to slow up first, because that kind of orbit analogy we were talking about earlier. So the higher we go, the more fuel we spend. But at the same time, if we don't go high enough, then we get the drag forces that you were indicating about earlier. So we actually do keep somewhat of a drag force, because then it becomes a problem so our concept of operations is we launch the spacecraft. It takes the raw materials up to a larger satellite that performs the manufacturing process, and then the capsule brings home the finished product back to Earth. And so we have to pay two sources of fuel. First, the source of fuel in the capsule to bring it back down, but then also fuel for the satellite factory that remains in orbit to fight the drag we were just talking about. So the optimization function is interesting because it actually puts us at a very low altitude, because we would rather continuously fight atmospheric drag a little bit and therefore save a lot of fuel on the capsule. So the net amount of fuel used for us is lower if we have one of the lowest constellations that exist.
So your manufacturing capsule is actually constantly accelerating to overcome drag.
Long term, yes. So at first we're actually going up higher because we have to go up on ride shares so that we can pay the bills.
And but they're not going to 100 miles; they're going to 500 miles or whatever.
Exactly. So it'll only be once our production rate is high enough to buy full launches at once instead of just a spot on a ride share is when we'll do that.
Describe ride share. What is a ride share?
It's just as it sounds, basically. Yeah, it's basically we share the ride to space with other satellites on the same rocket. So you can kind of think of it as like barnacles on the ship on the way up. Actually,
Remora. Yeah.
What's that? Yeah.
On a shark.
Yes, J-Bar worked. Some of J-Bar's coworkers back at SpaceX actually worked on the avionics interface between all of the satellites that would go up on a single launch, and making sure they all integrated and were put on the rocket properly and connected and hooked up correctly.
So, if NASA's paying SpaceX $50 million for a cargo delivery or whatever, I don't know what it is. They may have a little bit of room in the corner of their Falcon 9, and so you hitch a ride and you go where they go, and then you're in space. So when you do those constant accelerations, this is going to be an electric propulsion, I assume?
Long term, yeah. Whenever we have something permanent in orbit, and that's of course just because the ISP or the density of fuel is higher if you do electric.
Yeah, ISP is kind of like the gas mileage of satellites, specific impulse. Okay, so your company makes stuff in space, and being in weightlessness allows you to do what? Like, what kind of stuff would you want to make in space?
So I'll mention some products in a second, but just from like a conceptual point of view, if you like the analogy I like to use sometimes is if you're mixing, oftentimes in manufacturing, you'll want to mix chemicals for some sort of chemical reaction that you want to take place. And it's not always the case that those chemicals want to stay mixed. So a good example would be like the vinaigrette dressing in your refrigerator separates if you just let it sit. And that's because the stuff at the bottom is heavier than the stuff at the top, and gravity is causing that separation. So if you wanted to mix something that would separate like that normally on Earth, and therefore ruin your chemical reaction that you're going for, then you could do that same process, but in space, wait for the chemical reaction to complete, and then take the results and bring them back to Earth. So that's kind of one example of how eliminating gravity allows us to do new processes within chemistry and materials.
Very cool. And so, like, what stuff do I have on Earth that would be better if we made it in space? Or are you even, this may be trade secret. I don't know if you can talk about that.
So I won't mention any by name, only because like you said, there is a trade secret aspect there. And believe it or not, we're not the only manufacturing and space company trying to do this sort of thing. But I'll just speak in generalities. Pharmaceutical. So again, I guess I'll get to the analogy via first principles. The first principles, we have better control over chemistry and materials, and because it's still pretty expensive to get to space, obviously the cost is dropping, and that's why Varda is possible. But just because it's just now becoming affordable means that we still care a lot about dollar per kilogram of cost. And so if we think about, okay, we can manipulate chemistry uniquely, and what are the most expensive chemicals on Earth? Pharmaceuticals. So pharmaceuticals is a killer app. Fiber optics is a killer app. Silicon wafers, crystal growth in general has been largely researched. A lot thanks to you, obviously. You're kind of our R&D department, quite frankly.
Well, the ISS is R&D. It's great for R&D. It's terrible for manufacturing. But it's subsidized.
Don't tell our competitors.
Well, it's I mean, no one's going to build a factory on the ISS. That's just not what it's for. But it's for government subsidized science projects. And most of them are never going to go anywhere. But if some of them are probably valuable. So the ISS is a great place to do research, but it's not manufacturing.
I actually think it's a better question for you who worked in microgravity.
Yeah.
What products should we pursue?
So actually the reality is astronauts don't really know. We do these experiments, we plug the box in, we flip the switches and then it gets sent back to Earth or the scientists get it. So after a mission, you'll go through this debriefing phase with all your scientists and you'll get reports and, about a few things. But, a lot of that science is just kind of, it happens. And if you're a PhD astronaut and you're the world's expert in DNA sequencing, that's great. But I had 250 experiments. So the DNA experiment, I would know everything about. And then the other 249, I'd be learning for the first time, just like everybody else. So astronauts are more like lab technicians where, you see stuff. One of the coolest ones was this thing called CFE, capillary flow experiment.
Ooh.
And we had this, it was bigger than this. It was like those tubes at the bank that they used to, you put it in and it gets sucked away to the bank teller. And at Mission Control, that's how the back rooms used to communicate with the flight controllers. They would get a plot and write some stuff on it and send it through vacuum tubes. And it was full of silicon gel. So it was kind of like pancake batter, and it had a spatula in it. And as the spatula rotated, the fluid would get moved. And I was manually doing half degree by half degree. And then it would get to a certain angle. And all of a sudden, all the fluid would move to the other side. And it was fascinating. Like, why is this happening? But it's capillary flow, whatever that is. I'm just a fighter pilot, but fluids move based on the geometry of their container is the bottom line. And so if you got a satellite and you want to get every drop of fluid out and you don't want to have a helium tank that lasts for 10 years to push it out with gas, you can use geometry to move fluids in space, which is interesting. I have I'll tell you offline when we're done, but a experiment with M&Ms in a ball, and basically wherever it was on the ISS, all the M&Ms would move to one side, which really, it was like, why is that happening? They should be floating around, but they weren't, because they weren't in the center of gravity of the ISS. So
oh, interesting. So was it the actual the mass of the station itself was having an effect, or is that, or
no, I don't know. Gravity gradient.
Oh, okay.
Different orbits.
Slightly different.
Got
orbits.
it. Oh, right. Wow, that's awesome. That's awesome.
We'll talk offline about that when we're done. So anyway, it was little things like that. Watching a lot of them were biology experiments on my own brain, but that CFE was probably the coolest material science that I saw for sure.
Wow. Well, we got some good ideas now for M&M for maybe product number 5.
Yeah, M&Ms in space.
Yeah.
If you put beer or fly some whiskey, and everybody will buy it just because it was flown in space. That's probably the best thing. What kind of dollars per kilogram do you need to get to be economical? I guess it depends on if you're making whatever M&Ms, it would have to be really low. If you're making high value something or other, it could be expensive.
Yeah. So just back of the envelope math is around $62 per gram is the value that we need to capture if we want to have a product in today's paradigm. And of course, we work, part of our jobs every day is to work towards building the hardware so that we don't have to re-enter the manufacturing material, the manufacturing satellite every time. And so if we can reuse it by keeping it in orbit and having rendezvous, then that price can drop by an order of magnitude to around $6 per gram. And so that's the value we need to capture in the near term while we're still a startup. It's $62 a gram, and in the long term, when we hit our our highest aspiration as a first industrial park off the surface of the Earth, then it'll drop to about $6 per gram, and even lower as launch costs drop. But that's with today's prices.
So kilos 1,000, so that's $62,000 a kilogram, and there's 2 of those, so that's 35 grand a pound for the Americans.
Exactly.
$62,000 per kilo or $35,000 a pound. That's a lot. So you have to find a material that you can sell for $36,000 a pound or $63,000 a kilo. And there's probably materials like that.
Right. It's like, for example, the active ingredients, only the active ingredients in a pharmaceutical. Right. Exactly. Yeah. Exactly.
Well, I'm working in a business. We're making graphene as our byproduct, and it's very useful in things like asphalt and concrete and rubber tires and coatings. But the whole concrete doesn't need that. It's just a very, very, very small amount that you need to add. So that's where that value add becomes economically viable. So that's does that help drive like what materials are we going to manufacture? What can we sell for a really high price, and what would be made better in weightlessness, I guess, is the other factor.
Exactly. If you so you can take the whole world of products and manufacturing process and apply the filters that you just described. Can we capture the dollar per kilogram? Does microgravity or zero gravity help increase either performance or capability of that manufacturing process?
Right.
Can we put it in space, and can we integrate into that supply chain? So if the answer to all four of those questions is yes, then we have a product on our hands.
So I know, and you can't talk about the specifics because of trade secrets, but you would probably agree that people should spend a lot of money researching making chocolate candies in space. If they should focus on that. That might really help their be profitable.
It is intimidating, although we have a huge advantage in 20 years of ISS literature to go through. So
that's good to know.
Yeah.
Actually, yeah, it was your work that makes it possible. We certainly would not have the research.
Yeah.
NASA would love for you to go visit Congress and honestly, and you could be a guest witness to testify on behalf of the space station. That is really good. That is really good to know. And this is what's so cool. This is not, this is a new startup company. This is what you guys are doing are literally what America's all about. And you're hiring, right? I mean, there's people getting paid a salary. You got your private jet.
There's 30 of us getting paid a salary. Yeah.
And you got your private jet and your golf.
Just the fuel pump.
Your private Cessna 172.
Yeah, exactly. Yeah. It works 99% of the time.
We had this conversation a year ago. Well, why'd you go to California? Why not Texas? I was trying to talk you into Texas.
That's right.
I love California, but why Cali?
J Barr said he wouldn't move.
Because they didn't want to move.
No, J Barr said he wouldn't want to move. Yeah, that, and I did a heat map basically. I wrote a little Python script to scrape LinkedIn and some other hiring sites and look for the type of engineers we would need, and then just did a heat map across the United States. And Los Angeles and San Jose was actually another contender, but yeah, J Barr broke the tie there.
So there's this conception about California, and it has all those problems, and it does have problems, and the traffic sucks. I love it. I love California. I just can't afford to live there, but there really is, the talent is real. That's a real thing.
Yeah, and I was willing to move.
Oh yeah. Just not to any area. Some areas,
I spent a ton of time in Texas, especially in Waco, and more specifically McGregor First Base. So Texas has a spot in my heart, but it's exactly what you're talking about with as far as the engineering workforce. It's always a little bit easier to recruit.
Oh yeah. No, I get that, but I'll tell you what, the house I live in the suburban Houston is not as expensive as the house you guys live in. I know that for sure. And the state income tax I pay is less than the state income tax you guys pay. But on the other hand, I really miss California, and I can't wait to go back out there. So there's pros and cons everywhere.
Well, you got to come for a tour next time you're here.
For sure, I will. I haven't been there for 2 years since. I will be out there soon, I hope, for sure. Varda's on the top of my list. What did you guys learn starting this business? I mean, here you are, engineers. Do you have MBAs? Did you get any business training or?
Not officially.
You're I have more confidence than I have brains, so it's probably
That's I might I don't think my girlfriend would disagree about that one either. No, what happened was, so J Bar was has looked at startups before. I've looked at startups before. Started a small group investing into other startups that started basically just as an email chain between me and some buddies looking at pitch decks, but it turned out to be like a great way to learn about startups because we would care enough to do the due diligence because it was our own money that we were investing. So it was basically like forcing us to do the homework, and it was a little bit of equivalent to an MBA in the sense that we got to meet the founders, learn from their success and failures. With the investor updates, you get a front row seat to 10 case studies of startups, and you just take it from there. You play a lot of Monopoly with your family, you put it together.
Yeah, Monopoly was awesome. But I mean, the financial stuff, you probably have a proper CFO. I'm guessing, hopefully it's not a SpaceX engineer.
It's not a SpaceX engineer.
It is. Am I talking to him?
I learned a lot about finance this year.
So you're really the CFO without a finance degree?
I'm not. We have a proper finance hire. So shout out to Alex on this podcast.
Yeah.
He's keeping the ship afloat.
Good.
I think actually to answer your first question, as far as lessons learned, I think the operations stuff was very eye-opening for both of us.
Yeah.
So human resources, finance. I learned a bunch of IT, InfoSec, that sort of stuff last year. And man, that it's really, your company's built on that, is how efficient you can run.
Do you have a cybersecurity, is that on your radar?
It is, and we're very much ITAR. We're subject to ITAR, which is International Traffic and Arms Regulation. I think it's the acronym. But it's we have to keep our data secure, especially within aerospace.
That is hard to do, man. There's a lot of people watching this podcast that are going to be trying to hack you, honestly.
Well, thank you for the extra cyber attacks.
No, I don't think it's a threat to everything nowadays. So you gotta, if you're thinking about starting a business, you need a cybersecurity plan. I can say that. Yeah. So how's it going? When are you guys launching? What's the future look like?
So we purchased our first launch from SpaceX, actually. So we're going up on a Falcon 9 in 2023.
Wow.
So
that's awesome.
Thanks. Yeah. It was pretty cool. Like the guy, we wrote it. Yeah, well, I guess it was a wire, but yeah, we did.
Wow.
Yeah.
That's amazing.
Yep. So down payment on the launch is there. We got to a few of the folks here who used to work at SpaceX got to go back as customers and park in the VIP. So that was I'm sure a fun moment for the gang. And then, we're basically, the primary focus right now of the engineers is that first launch and building, integrating and testing the spacecraft that'll go up.
So that's not going to be a big producing satellite. That'll be your test vehicle.
Exactly. Yeah. Every aerospace company does their demo flight, and so we'll go up to show, prove that we can go to space, that we're competent individuals who can follow FAA regulations and bring something back down and that sort of thing. So it'll be a smaller spacecraft for the first mission, and a smaller reentry capsule.
Do you want to talk about your reentry system? It's pretty cool.
It is cool. It's bordering on trade secrets, but I'll say what I would say is one thing I'll note is that it's nothing super new in the sense of there's no aspect of the technology that hasn't been tested in some form or another.
That's good.
But it's pretty neat. I'll really looking forward to kind of talking more about it next year when we feel that success is imminent.
Right.
I think it's worth mentioning. Yeah. I always mention the opening scene in Star Wars: A New Hope.
Oh yeah, little
pod C-3PO or no R2D2 goes in. So similar concept.
That's actually, we should say that more often. Yeah, that's a great visualization.
I love that. Well, it's cool. A lot of people have launched things into space and very few have brought them back to Earth. As a test pilot, I always found the reentry is more challenging. The launch is more spectacular, but man, it's hard to get stuff back from space. A lot more countries and companies have launched than have returned. So
yeah, where to put all the kinetic energy can be tough for sure. I mean, if so the amount of energy just by being in orbit, is 1/2 mv squared, and v is 17,000 miles an hour. So you square that's got to go somewhere before you come back down. And so
the kinetic energy is in this giant, huge rocket going up, in the same exact amount as in this little small ball coming down. So it is a very cool problem. Well, that's awesome. So you guys are manufacturing, but talk about what other aspects of space are there. There's rocket launch, there's space tourism, there's communication, there's military, there's what else what other kind of companies are there out there?
You touched on a few of them for sure. I think of it kind of in like the historical time. There's a ton of different ways to think about it. Either, market analysis, there's components and then operators, et cetera. Or the way I always think about it is like historically and it kind of runs a similar trajectory, no pun intended, as other industries, where at first it's military funded, then kind of a telecom, then manufacturing, and then tourism. Similar story of, thinking about like where human history has been before. It's usually either there's a military involved that pushes the technology, or there's some outpost in a new colony or somewhere like that for telecommunication or talking with others. And then, okay, now maybe we can actually manufacture, and then, let's actually go there now as a hotel, and it kind of pops up similarly. So I would bet the space industry creates actually, I forget what the guy's name is, a really good TED talk on this, but he called it space, the space economy, more so than the space industry. You can kind of see it develop in much the same way as previous economies have developed, or at least that's what one would expect if you can only look at the past.
There's mining, potential asteroids and moon. That's another aspect. Of course, there's just pure government exploration. There's not really revenue there other than the government contract. There's a lot of different things happening. So I would assume, I don't know what you guys think, are there going to be a lot of dead bodies here in the space economy? And if so, which,
it's too, I think
yeah, I got $1 million. Where should I put it besides Varda?
Besides Varda, I would say think about what you want to see happen, and then put your money there. And what I mean by that is there are folks who work at Varda or at other companies as well that their passion about space comes from exploration. It comes from science. I know that like one of the most inspiring things in space for me is the Huygens probe. I mean, landing on a moon of another planet, how long ago was that? It was well over 20 years ago, I think. Just super awesome. And we have a picture from, it's crazy. So, and then even more recently, pictures of Pluto and stuff like that. So, I mean, that I think is inspirational to a lot of the engineers. So there's the exploration aspect, there's the science aspect, which it's like any other culture. There's always subcultures within subcultures within subcultures. And so there's some that like the science aspect of exploration. There's some that like the science aspect of, just why are the rings of Saturn the way they are? Why is there this is actually interesting. I was just reading a Wikipedia article. There's a hexagon on the pole of Saturn that develops from the fluid dynamics of the clouds. And it's like, viewers, if you want to Google Saturn hexagon, it's super cool looking. And like, why does that appear? And so, I think then there's Varda. I think most of the folks here are excited about the economic buttress that space companies can have to support one another. So I guess like a good example would be, Saturn V doesn't fly anymore. The moon rocket, shuttle doesn't fly anymore. And if there was a strong economic driver to force them to continue to have flown, they would have had a better chance of surviving in perpetuity. And so part of the reason I'm excited about Varda is because by being a company that drives a lot of launches means that hopefully we have a different fate for Falcon 9 and the other vehicles that are coming online now in the space industry, so that they continue to develop and increase cadence and look more and more like airplanes rather than before. So, I mean, it's a totally different passion almost, but space brings it all together.
Yeah, that's a good way to look at it. The economy. I mean, if there's a demand and there's money there, then there's going to be businesses that jump in there and fill that demand and make money and provide jobs. And if it's just government exploration, there will be some, but it'll be based on the whims of politicians, and it won't really be long term. So that's a great way to look at it. The space economy. And by the way, Huygens was the probe that was part of Cassini.
Oh yeah,
that went to the Titan.
Right? Yeah,
the big moon of Saturn. So I love that stuff. I made a short film last year called Cosmic Perspective. It was about space photography, and I'm hoping to get it turned into a TV series about space and how it's changed our perception. But there was one episode that we did about all these probes that went out, and they're just so cool. When I was a kid, Voyager was going.
Oh, awesome.
Voyager's one of my favorites as well. Like anyone,
it's one of the most amazing things humans have ever done. Launched on July 4th, I think. No, that was Viking. Viking landed on July 4th. Voyager launched. Anyway, went to Jupiter and Saturn and Uranus and Neptune, and they both left the solar system, but one of them is still operating, I think. Anyway, I was a kid. I had, and back then there was no internet or Twitter, so I had to wait every month to get my astronomy magazine. Literally, I'd get my astronomy magazine. I'd read the whole thing in a day, and then I'd have to wait another month to get the next one. It was really cool. But hey, guys, thanks for coming on today. This is amazing. What you're doing is amazing. Hopefully, it'll be successful. I wish you the best of luck, and opening up a new frontier of the economy in the most direct way. I mean, you're making stuff in space, which is pretty amazing. And you've gotten funding. I mean, you've gone through multiple. We've talked about this. So I mean, 30 employees. You wrote a check for their first launch. That's really exciting stuff.
Thank you. Yeah, appreciate it. And thank you as well for your time. It's always have a blast shooting the breeze with you.
Yeah, this is fun. So if I'm an investor, how do I find out about your company and look, this is your time for shameless self-promotion.
If you're an investor, you already know about us. No, I'm just kidding. Coming back, down to earth, I'd say coming down to earth for a second. Feel free to reach out, either myself or through our website, varda.com. And we're happy to talk to anyone and share our passion, especially with our plans forward. It seems kind of straightforward, and also at the same time a lot of fun and exciting. So
it's cool. It's cool stuff. Actually, well, you're right. I should have said that at the very beginning. I'm probably your smallest investor, I'm sure. I am an investor, so I have
got to get the disclaimer out there.
I should have said that right up front. It's a very, very small amount, but I think what I think I might do is have a Twitter poll and let people tell me if they think I should sell all my shares of Varda. Watch out, your stock might tank if I do, but all right.
Well, we're honored to have you for sure. Yeah. Says a lot. Thanks, Terry.
Cool. Thanks, Terry.
See ya.